Ladies and gentlemen, welcome to our presentation. My name is David Rico. I'm the co-lead of the capability area logistics and transportation management, and also the lead of the so-called SAP Automation Factory. Today, we are going to demonstrate our use cases. So we were working really hard on the devices you see behind of me. And for the presentation, we have three parts. In the first part, I will introduce our ideas, so our concept, why we came to the idea to a fully automated production supply. In the second part, we are going to see a live system demonstration, where we are also going to see how the devices behind of me connect and work with each other. In the final part of the demonstration, I will tell some closing words, just in order to register everything again, what we have said and also what we have shown. So the production, the fully automated production supply is an idea that we generated just in order to put some use cases together. And we see it in this slide, what we pretend behind of it. So it is a complete business scenario where we integrate mainly three components. The first component is a so-called automated storage and retrieval system. So one example of this kind of devices is a automated high bay. What you see in the left side of the slide is actually a real high bay that we implemented by Deloitte and at one of our customers in the Cologne region. So you get an imagination, what is that? So a high bay is a huge building with a lot of storage bins, so positions where you bring material inside and also outside. And this specific one, is 60 meters high, and it had a quantity of 24,000 storage bins of double-sized pallets. So a lot of capacity. If we put it in numbers so that you can have a better imagination, is the capacity of approximately 10,000 trucks. So a lot of material. Spare parts that we stored for the complete European market. The second component of this fully automated production supply process is a robotic arm. So in the reality, you see it, of course, in the production line of the different, of course, of our clients. So in the automotive industry, you see it for welding, for printing, for just manipulating or just moving material. That's what we have also in a small scale. And at the end, what we have in order to move the material from A to B is a so-called AGV, Autonomous Guided Vehicle. We are going to get to know what is that. But that's the reality. So the idea behind of it is to use of course, the benefits out of automation, out of Internet of Things that we have in the list, like simulation, like rapid prototyping, predictive maintenance, machine learning, and to put all these ideas into something a little bit more feasible and explainable for our customers in workshops. So we came out with some prototypes. It begins with the high bay from Fisher Technique. Is what you see here in black and red. There is where we store the material. We put it also out for the customer demand. We move the material with conveyor belts and hand it over to a robot arm that in our case is called Dobot. So it's the second device we see here. Once the Dobot take over the material, we place it onto the AGV. So we see three small ones here because they have a so-called swarm intelligence. They can talk to each other. They have a own intelligence. And for example, if we have different positions where the material is coming from, then they are able to talk to each other and say, hey, I'm the closest one. I will take over this transport. This is what we are going to see here today, but the idea is to make the link to a fully automated supply chain, and that's why the other part out of it is the connection to a lean manufacturing. So this is one SAP use case we already have at the digital factory, and that's what we, in a very small scale, have at the end of the room. And we do the production of excavators with this lean manufacturing. We use Google Glasses, smartwatches, tablets, and applications so that we support the assembly of the excavators. And that's the complete vision of our devices and use cases. This kind of business scenario is something we can deploy very accurately for, let's say, customers that need a specific handling of material in terms of dangerous goods. Sometimes some of our customers, they have very heavy materials to move. And of course, this cannot be done by human. That's why, yes, the idea all about these use cases is to move the material out of the storage place to the production line without no human interaction. So all fully automated. And why we call SAP Automation Factory to our team? Because we deployed or we developed a methodology how to bring these innovation ideas into quick, real automation use cases. And for that, we use a 5-step approach. The first step is the configuration of the SAP system. Also, more specifically, in our team, our focus is EWM. EWM is Extended Warehouse Management, so the module in SAP we use in order to move the material inside of the warehouse, outside of the warehouse to deliver the products towards the customers. And that's the first step. The second step is the configuration of the handshake system. So, meaning the middleware. And in our case, we use two middleware, so SAP PI, PO. For some of you that maybe you know what the term is, so it's just a system that just do mapping between SAP systems and non-SAP systems, and the PLC. So that's what we are going to get explained a little bit later. The third step is the configuration of the material handling equipment. So that's actually the device executing the movement. In our case, so the highway, the dobot, and the AGV. The fourth step of that approach is the configuration of the SAP Cloud Platform. Because in the cloud is where we collect, aggregate, visualize, and also condition the data we get out of sensors so that we can trigger the fifth step of our approach, which is the follow-up actions that we trigger back again in SAP ERP. For example, the creation of purchase orders, the creation of maintenance orders, the creation of any workflow that could help and automate the processes behind. With that, just let us keep it short with the explanation and the slides and the theory, and let us go to a system live demonstration of the devices and the systems. For that, Tobias, your stage.
Thanks, David. So welcome also from my side. My name is Tobias Pelzer. I'm also part of the capability for logistics and transportation. I'm also the co-lead of the SAP Automation Factory. And today I will present you our devices and in a live demonstration. So first of all, I want to explain what we actually see here, because you see a lot of devices and it might be confusing. So what we see here is actually one of those middlewares. This one is a PLC, and some of you might think, now, okay, that looks just like tools or whatever, but to be honest, this is really the highest industry standards. That's a Siemens PLC, so this is also used for all our customers in the industries. And it's completely controlled and steered like we do it at the customer side. Okay, going to the next part. Here we see a sorter. So you can sort parts, for this case, by color. And the next three parts that you see are called the high base itself. So how is our high bay use case built up? So every high bay has 9 storage bins in total. And you see a rack feeder. And this rack feeder is able to move in parts into the storage bin and remove them again. So it will remove the part out of the storage bin, place it onto a handover point, what we see here. And then we have a vacuum gripper that will suck the material and put it onto our conveyor belts that we see in the front. And the conveyor belt will move the product to the end. So coming to the end, we come to our next use case, the Dough-bot. So this is also an industry robot, and you know it also from automotive companies. They're a bit bigger, yes, but the technology behind is still the same, okay? All right, coming to the system, because we will trigger it from our SAP systems, of course. And therefore, we start in SAP ERP, what I guess everyone knows. We will start, of course, with a production order, because what we want to do is we want to supply the production line, actually, and therefore the production order could be created by a just-in-time or a just-in-sequence call. So for our use case, I already created a production order in advance. So we will quickly have a look inside how a production order looks like and what do you need for it. So at least you should tell the system what product you want to produce. So we see here the product is called AGV FG1, and that will be the finished good afterwards. You also see the quantity that we want to produce, and what is really important, the components. The components that are needed to produce our finished good in the end. And this one is called a bill of material in the ERP system. And for our use case, we said, okay, we need 20 pieces of our raw material in order to produce 10 pieces of the finished good. So this production order in the end is somehow released, and this can be also completely automated. So I will release it by hand now. And of course, we have some calculating costs error, but no one cares about costs. Huh? Okay. Now, by releasing this production order, we see in our system that now actually we are not talking anymore about moving the production order to a different system, because now we are working on S/4HANA, so it's just changing modules, right? So in ERP we created the production order, but now from the EWM point of view for the logistics, we will receive this order now and it will create a production material request. This means the system now says to the logistics, okay, I need 20 pieces of my raw material that you see here in order to create 10 pieces of my finished good in the end. And of course, EWM will trigger movements to move the raw material to the production line in order to stage the materials. So now our raw material is still inside of the high bay, and the process we already saw that was explained by David is that we will remove the products out of the high bay. The Dough-bot will pick it up and place it onto the AGV. The AGV then will bring the product to the production line. So we need to go to the staging transaction. This will actually trigger the staging, but this one is a report. So everyone who knows a report, this can also be run in the background and can be fully automated. So if I now click on the execute, because we are demonstrating a fully automated process, we built in some manual steps just for the showcase, because then we need to hand over to colleagues and they will give you more information about the AGV. So if I execute now, hopefully the system will run, and we see that 2 movements were created by the system now. So what we see now is that the rack feeder will get the material out of the storage bin, will bring it to the handover point, and then the vacuum gripper will suck it up and place it onto the conveyor belt. So from there, it will be moved towards the doughboard. And now the doughboard will pick up the material and place it onto the AGV. So maybe we need to work with the dimensions, but looks quite good. Thank you. Okay, but to let you guys know, we are not making a show out of it. It really works. You see here in the system, in our EWM system, the movements that just happened. So to give a short explanation, we have a warehouse task. So it is called a warehouse task. It's a movement for us. So a movement saying, okay, go from storage bin A to storage bin B. So what we see here is the movement out of the high bay onto the handover point for the doughboard. And then we see the warehouse task from the doughboard onto the AGV. And with this, we come to the AGV. So this is the stop here. And I will hand over to our colleagues, Sander and Andreas.
Thank you so much. So, hello everyone. My name is Sander Groene. I'm also a member of the capability area logistics and transportation. And next to my regular project work on the SAP Extended Warehouse Management, we spent a lot of time, for me, mainly on the AGV use case, Autonomous Guided Vehicle. So, actually, you just saw the movement already from the raw material, from the pickup point, from the doughboard, and it was already dropped on the AGV. But the AGV didn't move yet. And that's because we have now a small mismatch. For the system, the raw material is still on the pickup point. And at the moment in time, when I confirm this movement also in the system, then it's the trigger for the AGV to start moving in that direction. But before I do that, I would like to do 2 things. First, I will open the other thing, because it's very nice that we have here an automated solution to bring products to production. But there is way more value behind this scenario, and we want to show you 2 Internet of Things scenarios that we also implemented around the AGV. The first one you can already see on the screen. And it is supposed to show during the physical movement. It will also show this movement in real time in the system. So before I start the actual movement, I would like to give the word to our other team member, Andreas Strenkle from KIT, to tell something about himself and about the AGV.
Yeah, thank you, Sander. So, my name is Andreas Strenkle. I'm from the Karlsruhe Institute of Technology, and I work at the Institute for Material Handling and Logistics in the group of robotics. And we brought our AGV today, and I'm going to explain you something about the software we developed for the AGV. So, for AGV, it's a difficult task to localize itself and to navigate. And we have a solution here that doesn't need any landmarks, for example, lines on the floor or any magnets on the floor. Instead, we only use the sensors, the eyes of the AGV to do this navigation, and therefore we build an initial map of the whole area. So we did this morning. It took just 5 minutes because this area is really small. And then we use this map information for the robot to navigate in this map. So when sender will send me the warehouse task, we will see that the vehicle will start moving. Sender, please, if you could send me the task.
Yes, I will do.
And then it's interesting to see the visualization on the screen where we see the position of the vehicle. And we will also see that the vehicle starts moving, and it doesn't just move, it also navigates around obstacles.
So what I will actually do, I'm not literally sending the message, but I'm now executing the movement from the Dobot, by the Dobot in the system.
So now the vehicle received the task, and it uses the map to plan the path. And of course, the map, if there is no obstacle within the map, it plans the straight path to the goal. But if I step in the way, it starts replanning, so it detects me as an obstacle and then plans around me. So if someone of you wants to try to step inside, you can also move around the vehicle if you're brave enough. But until now, we didn't crash in any people, so it's really safe. And the good point of this kind of navigation is that it's very flexible. So if you change something, for example, if you move the sofas, the vehicle will detect that. Oh, one of you is brave. So it didn't hit you. Great. So if you would move something in this area, the vehicle would detect it. And if there are some more vehicles in this area, it will communicate the updated map so that the localization and the navigation will be stable for a long time. So now we reached our goal point, and we can also see that in the system. And with that, I will hand over to Sander.
So here on the system, on my right hand, for your left, we see the actual path that was followed by the AGV. And what we will see is that also in the system, if I now refresh the screen, I see that the movement from the AGV to our production area was also confirmed. We can see it here. So that means that by now, the products are available at a production line. So a little bit more before I want to tell you something about this IoT scenario, because it's very nice that we can see here the visualization. But for example, based on this data, we could, if we provide this as a service to the customer, we have all the data about the movements that were executed, and you can actually then send invoices based on the movements that were executed by the machine. And the customers don't have to buy these machines, for example. So that's about the visualization. We have more sensor data. So we have the location, and we have the battery data. You can see here on the other screen, so we call it from sensor data through insight to action. We also want to show you some action. And then it's not physical action, but action in the S/4HANA backend, that actually later on things will happen. So we have 4 steps here. Create is the creation or definition of the sensors inside the AGV. And the sensors, they can mean they provide this location data real time, but also information on the battery, for example. So this information is then aggregated in our SAP Cloud Platform application that we built. And you can see it here. For the battery, for example, it's giving us 2 different values. State of charge, you all probably know it from your mobile phone, how full is the battery still. But we also have a second one, is the state of health. And this value tells us something about the healthiness of the battery. And if this percentage is going down lower than a certain threshold, then it's a sign that over time there's a bigger chance that this battery will actually die. So here we are in the area of predictive maintenance, and we are analyzing this data, and apparently, luckily, it's not the real data about this AGV, because currently we see that the battery is dying very, very fast. This is a simulation, but we want to show that we also fulfill the last step. After the analysis, we act on it, so we see, oh, the state of health of the battery dropped below a certain threshold, and then the SAP Cloud Platform is triggering the creation of a maintenance order in our S/4HANA backend system. And this I can show in the system. So let's go to S/4HANA, and I show it from the stock requirements list. So there's not only the maintenance order, clearly we also need a replacement battery, of course, otherwise the maintenance guy comes and there's no battery. So based on the order that we will just see, we will see that also immediately a purchase requisition is created for a spare AGV battery. So let me open this list, and we see we have more AGVs running, so there are a lot of examples. So what are we looking here at? So we see here an order reservation. This order number was created, and we see that we need for this one replacement battery. And because apparently there's an available quantity of 0, so the system automatically created a purchase requisition for it. So it can now be purchased really quick. So we can, from here, we can also look in this order. So we see the whole order, including all dates, and work centers where it will be executed is already included. And we can also see here the component that is required. So based on, it can also, in this case, we only defined the battery sensors in the system, but you can maybe imagine that if we define way more sensors, we can do this also for all kind of other components. So with that, I would like to close the AGV part and give the word to David again.
Thank you, Sander. So just in order to spend some closing words on the presentation, so I would like also to say what we have out of this, because yes, it's fancy stuff, also expensive stuff, but what do we have out of it? So of course we have the possibility to explain it better to our customers in workshops, but also we try to calculate a business case out of it. So if we just take as a base the automotive industry, and I'm not saying that we only can sell our process and our idea to the automotive sector, but if we just take that as a base, and if we look in the slide, so we see in the left side 20 of the 200 biggest companies in Germany are in the automotive sector. All of them, so all 20 of them, they use SAP ERP as the backbone in the system landscape. And out of these 20, we already do business with 10 of them. So if we just take this as a market, we extend our SAP service offerings, we could expect in the first year sales of about 4 million. How do we plan to do something like that? Of course, a roadmap is necessary, a strategy is necessary for that. The first action is to pre-sell. So explain this use case to our customers, maybe that they visit us in the digital factory. The idea is also to place cameras, web cameras in the digital factory so that we can access these use cases and run it 24/7, all the time, via internet. But of course, visiting the location in the digital factory is a good idea as well. To participate actively in trade fairs, like for example in the SAP Info Day in November. The next activity would be the creation of assets. So the idea is to create out of what we have won as knowledge, white papers, to create also, for example, the integration of further SAP use cases, to fine-tune, of course, our use cases a bit more, including more complexity. And for example, from the today's session, we want to make a short video in order to initiate social marketing. One very specific action that we are going to have in June, that's the final step, is the presentation of our use cases in the Day of the German Industry. This is a trade fair taking place in June in Berlin. And with some luck, we are going to showcase these innovation ideas to Mrs. Merkel. And probably we are going to be in the television as well. So all these, guys, yes, is very exciting. We spend a lot of time in here, a lot of, yes, really too much work. But it is not possible with one person or only with the 4 persons displaying today the ideas. It is because we have a huge team behind of us with different skills. It's not only SAP, it's also in the complete service line that we have the support, but also in the USI. So we have some people in India working till 4 a.m. to solve our problems in the firewall if it is necessary. And that's a success story. So it's a big school for us in order to increase our knowledge, because innovation means we are creating a new path in order to discover something that it was not there before. And in this point of time, I would like to say thank you to all the team participating and putting a lot of effort behind of this, because, yes, it pays off. Thank you so much. And if you have any question, please don't hesitate to reach out. Also, if you want to display this to your customers, or where you are doing the projects right now, please reach out to us. We will be happy to provide you material to also to showcase this in front of your customer. And yes, thank you so much.